I think Guam has its own unique challenges, but overall, I mean, we're dealing with aging infrastructure and infrastructure we built quickly, right? So I think we know more now than we did then. And so it is difficult to build at that same pace that we built, when we were really developing, um, you know, America, right? So
Yeah.
it's a different game. And I think, like I mentioned, cost, right? It's very expensive. Labor is expensive, materials expensive. So we need to figure out how to do things more efficiently.
Haatveit, it's your innovation coach, Rob Jackson, and welcome to another edition of the Innovate Guam podcast, the podcast where we explore all things innovation, technology, and improvement related to the island of Guam. Don't forget to like, subscribe, and follow me on YouTube, Facebook, LinkedIn, Instagram, and Substack. My podcasts drop at the beginning of each week. Also, be sure to check out my Innovate column in the Pacific Daily News every first and third Friday of the month. All right, I'm really excited today. Today's guest is Caroline Haatveit, a licensed professional and geotechnical engineer who leads the Guam office of ENGEO, an internationally respected engineering firm with more than 5 decades of experience solving some of the toughest ground related challenges in the built environment. Caroline works at the point where infrastructure, risk, and reality intersect. Her experience spans public, private, Department of Defense projects, including ports and waterfront facilities, bridges, airports, utilities, telecommunications infrastructure, industrial developments, and large scale campus construction. She is licensed as a professional engineer here on Guam and holds professional and geotechnical engineering license in California. NGO established its Guam presence in 2020, and under Caroline's leadership, the firm has quickly become part of the island's infrastructure ecosystem, supporting agencies like the Guam Water Authority, the Department of Public Works, while also building local testing and quality assurance capability. Notably, NGO's Guam Materials Testings Laboratory earned accreditation from the American Association of State Highway and Transportation Officials, commonly known as AASHTO, a major milestone that strengthens the construction quality control on island and reduces reliance on off island testing. Beyond her technical work, Caroline is known for her commitment to mentorship, her commitment to servant leadership, and her values driven engineering. She's written and spoken publicly about aligning engineering careers with personal purpose, an especially important message as Guam looks to grow its next generation of engineers and infrastructure leaders. What I love about Caroline's world is this: before anyone places concrete, drives piles, builds a runway, or opens a port, the ground has to tell the truth. Geotechnical engineering is where reality checks happen. And on the island of Guam, those reality checks matter more than almost anywhere else. Ladies and gentlemen, help me welcome to the podcast Miss Caroline Haatveit. Caroline,
Thank you
welcome
so
to the
much for having
podcast.
me. Yes, I'm excited to be here. Thank you, Rob.
Well, I'm so excited to have you. We start off the podcast with a tradition where we start off with some icebreaker questions to get a sense of where your head is at in terms of innovation. So, when you hear the word innovation, what does that mean to you? What's your personal definition of innovation?
I think innovation is using new tools and sharpening them. It's always trying to be 1% better than you were before, tackling a problem a new way every time. You're not reinventing the wheel. Everything is a new one size fits You know, we always want to look to the past, right? But how do we look to the future and how do we do things differently? How do we do it smarter, more efficiently, using the latest technology and tools at our fingertips? So that to me is innovation, is again using tools, new tools, sharpening them, figuring it out, getting your hands dirty and doing your homework.
Yeah, yeah, that's great. So, in your line of work, some of the most important decisions are completely invisible to the public. Can you tell us about a geotechnical decision, something that no one else would have ever noticed, but it made the difference between infrastructure that performs for decades versus infrastructure that becomes a recurring problem?
Yeah, that's an interesting question. I think, you may have seen in the news, right, that there was a big uh, bridge collapse in China, right? And I'll be honest, I haven't gone and done all the research and looked into what happened, but to me, it seemed apparent that, the structure was intact, right? But it seemed like there was a landslide, some kind of failure that essentially took out the whole bridge. And I think the thing about geotechnical engineering is when we do our job right, you don't notice, right? Everything is, you're driving across the bridge, everything's good, your building's stable seismically, right? But the ground matters, the context matters, right? Structural engineers do their thing, but we definitely do our thing, and it's really important for us to do our due diligence and look holistically at the built environment because it's about how the built environment responds to the ground, right? And so if you miss a slick seam and you disturb that ground and you basically destabilize a slope, it can have big consequences. And so, you know, that's a part of geotechnical engineering that is not it's sort of invisible to the public, right?
Yes,
Yeah. So
yes.
that's a
And I
big.
love the way that you refer to it as the built environment or the built ecosystem. I love that term. So let's step back for a moment. When you came to Guam to grow NGO's presence here, what surprised you the most about Guam, whether it be something cultural or technical or anything like that? What was the thing that surprised you the most about Guam?
I mean, Guam continues to surprise me. I think culturally, I mean, I've met an amazing community of people here. I've met a, resilient group of people. I've faced, different challenges that maybe I haven't faced, before moving to Guam. From an engineering perspective, I think you really understand remoteness and understanding what resources you have and maybe the most, cost effective, best solution that would be elsewhere is not practical or feasible here because the materials drive the cost up so much that, importing this and that. So you really have to work with what you have and the tools that you have. So it's forced a sort of different creativity in me, working within the resources and really listening to the feedback, right, from those around you, like, oh, I don't know about that, so I've had a lot of reality check moments, right, where your
Yeah.
brain kind of has to make that switch of what do I have to work with?
Yeah, and I love that word remoteness. Very good and very applicable to Guam. Innovation leaders, it's your innovation coach, Rob Jackson here. Are you ready to elevate your vehicle fleet operations? Fleet Solutions is an AI enabled fleet management system. Fleet Solutions provides real time video, smart analytics, and total efficiency. Keep your people safe and keep your business moving forward faster than ever before. Fleet Solutions, arriving tomorrow, today. Visit thefleetsolutions.net or call 671 988 9748 to schedule your personalized demo and revolutionize your fleet operations today. Let's talk a little bit about NGO. You know, uh, a lot of the listeners might not have heard of your company before. Can you talk about, the NGO story? Where did the company come from? What problem was it created to solve? And how has the mission held up over the last 50 years or so?
Yeah, thank you for asking. So our company was founded in 1971. by three engineers, Berkeley grads, in an apartment, I think in Berkeley. And now fast forward, we're about a 400 employee company. So it was three geotechnical engineers, and over the years, we've hired great people and expanded service lines, and most of our expansion has been, very organic based on the people that we bring in, their experiences, and what value we can provide to our clients and our projects. So it's been a very organic, people-driven growth, if you will. And I actually wrote down sort of our purpose. We had a big all hands meeting, so it's top of mind. So our purpose is to have every person achieve levels of growth, achievement, and success that they once deemed out of reach, to provide lifelong well-being of every NGO family member, and to elevate the standard in any service line we choose to provide. So I think that's the problem, or that's the mission, right? That hasn't changed over 50 years. It's always been about the people internally, right? The people at NGO, the NGO family, but also like our clients. So the clients become like a second family too, understanding their problems, pain points. They become our problems and pain points, and we figure out how to get in and, what can we do to help ease that pain, the pain points, right? So
Yeah, I
that's
like
NGO.
that broad definition and a big focus on the people, like you said, and really getting it from a people standpoint, not just about things and technical aspect. So I really love that.
Yeah, absolutely.
So NGO obviously made a deliberate decision to open this office here in Guam back in 2020. From your perspective, why was it important for NGO to be here?
I mean, it's important for NGO to be here. I think for one, I mean, the obvious reason, right? The work is here, right? I think there's a need, especially with all the work here, the build up and, aging infrastructure and this and that, right? For us to be here, practically. But, now that we're here, the way we serve this office, it's really important for there to be people here that understand Guam, understand the remoteness, the needs, the culture, how things work. I mean, coming here too, you learn that it's a very in-person place, right? So my career has changed a little bit where I'm going to do more things in person, right? Being in California, especially after COVID, I think there was a lot more of calls like this, right? Like Zoom calls, but here it's definitely like
Right.
oh, let me come into your office, so learning that, but then also really understanding, okay, what can we do here? What are our resources? How do we tackle this problem? So being here and really living it and understanding it is really important.
So curious, before 2020, was NGO supporting um, projects in Guam remotely from afar, or was that the first foray into the Guam market?
No, that was our first, we were asked I mean, we were deliberately asked saying, hey, we need more boots on the ground here, right? To meet this demand. Would NGO consider establishing an office in Guam? And honestly, this is not the way we typically establish an office. Usually it's more, we have that anchor project or we have that anchor client kind of establishing momentum and, just anchoring us to a place. So it was sort of a leap of faith, and, it was humbling, right? It took us a while to get our footing and to learn all the things I mentioned, right? It's a very different environment than other places. And so learning the ropes took some time.
Be incorrect in saying that like your big anchor and value add now is your AASHTO certified lab, that kind of is an anchor, if you will, for all of the construction and all of the different firms to be able to use that.
Yeah, I do think the lab has been big. Having the ability to run these soils tests and concrete tests in our lab. We have had um, a lot of samples come in the door, right? To have our lab is big. I think there was a demand for that here to have. So, there are a couple other labs too, but it was definitely big. And then we can, with the scaling up of all the construction here, we're, like I said, there is a lot of demand we need to meet, quick turnaround times, and so we're helping kind of, fill that space.
Yeah, very good. So where actually is NGO's where's the office in the lab?
We're in Harmon, so we're up just across from Pepsi in the Xora building. So our office and lab are in the same space, which we love, so that we can kind of go back and forth. And actually, as geotechs, we do get our hands dirty, and we have red dirt on our shoes. Like, if you know, you know, you've been to Guam, right? So we're in that space. So yeah, and our doors are unlocked. So come say hi, anyone if you want to talk about dirt and landslides and karst and a bunch of other fun stuff. We're around.
Well, I tell you, Caroline, I might take you up on that offer. In fact, I think I might love to come over and do like a tour of your lab
Yeah,
and check it
absolutely.
out. That would be cool.
Absolutely.
Um, so when a client hires NGO, what are they really buying?
I think when you buy ENGEO, when we have a professional service agreement, we engage and work together, you're buying the commitment to the highest technical standards we can provide, efficiency, speed, robust quality control, responsiveness, and out of the box thinking. I think we're going to look at your problem like it's a unique problem. We want to understand the nuances. We want to think creatively again, apply the experiences we have and find the right people, right? The right experience. Like I said, we're here in Guam. We have a presence in Guam, but we also have offices. So I didn't mention, but we, established in California. We have offices throughout sort of the west coast of the mainland, and then we're also in Australia and New Zealand. So we have 400, different folks that have experienced different challenges, and so we try to put the right people for the right problem and like I said, not a one every project is a one size fits one, right? We try to look at it as a unique situation and understand the complexities and try to have a very bespoke approach.
Yeah, yeah. All right, so let's zoom in now, because geotechnical engineering is one of those, not commonly understood disciplines, and quite frankly, somewhat even underestimated, particularly when you look at some of the structural engineers and et cetera, uh, throughout the architectural engineering and construction ecosystem. So
Mhm.
let's kind of dive into, what geoengineering is really. So for somebody with no engineering background at all, can you explain what a geotechnical engineer does in just plain language?
Yeah, sure. I mean, I kind of alluded to it, right? But it's the how the built environment responds to the ground conditions. So we're sort of the first people on the scene, so to speak, before anything gets built, right? We do an exploration of the ground. So it could be, doing test pits, which is digging holes and logging the subsurface conditions, or drilling a boring, getting, the samples for lab testing. We'll test them in our lab to get characterize the ground surface, engineering properties, and then we have to build the context for that, right? So it depends on the ground conditions as well as the structure, the vertical loading, seismic loading. The ground's going to respond differently to all of it. So we look at all of that, and then based on what's planned, we give recommendations. If you want to build X, you need to do Y and Z, and so on and so on. And then we put a report together stating, our recommendations, and then, depending on the project, we'll typically go out and observe and run tests during construction. So whether it's, piles, or if we're building in the hills and we need to do some remedial grading to remove some landslide conditions and key into bedrock, we'll go out, have our geologists go and make sure we've gotten through all of the bad material, so that kind of thing. So it's very much, you know, um, we do borings and we see, you're poking little holes in the ground, right? But it's important to really see, because we are dealing with, Mother Nature, right? There's no rhyme or reason why, so things change. And so adapting and to the site conditions during construction is really important too, so we can field fit. So that's sort of the broader context of what we do. So basically everything that's built. someone has looked at how those loading conditions will respond to the ground conditions.
So that's great explanation because it kind of sets apart what you all do versus other engineers. Um, the the layman might just look and say, "Well, that's just all engineering work," but specific kinds of engineers doing specific kind of tasks. So that was a good breakout of that. Can you walk us through the life cycle from first site visit to drilling and sampling to lab testing and on throughout the rest of the cycle? What does that look like?
Yeah, so it's kind of that, right? So like I said, we get a request for a proposal. Hey, NGO, we're looking at, putting this structure, whatever, say it's a 6-story structure on this site. Can we get a proposal for an exploration report? And then we look at the site, we characterize it. So sometimes it may involve looking at historic aerials, topos, doing a site reconnaissance walk, looking at, the geologic map and the conditions so that we can, tailor the best approach, whether we're going to do borings or test pits. We go out and we do the field work, we collect samples, we run them back to our lab. We'll have to do whatever associated analyses. Sometimes we have to run, settlement analyses. Sometimes we have, specific like seismic hazard analysis we'll need to run for structures, liquefaction analysis, whatever, obviously the context matters on where the site is and what the geotechnical hazards are, but we figure out what the hazards are, what we need to do to mitigate them, and then we write recommendations for them, and then they are in a report, and we present the report, and then, we always work with the design team right during design to figure out what the best way to implement. And we do, if we need to, tweak some things, value engineering, work with the structural, something, I mean, little tangent, but I really like getting in with the design team earlier. So talking to the structural engineer, what is your demand really? So that we can understand from both sides, right? Because if we're over here writing our recommendations in a vacuum, the civil's over here doing their thing and the structural's doing their thing, it's so much better just like everyone get on a call. We all have technology. Let's all talk about this together. So there's a lot of design consultation and figuring things out to make sure we optimize, right? So that's a bit of it. And then depending on, what the needs are, again, going out into the field and seeing it built and making sure it's, per our recommendations or specs. And so that's sort of the life cycle of a project from design to construction in like 30 seconds, whatever it was, a minute.
So it sounds like uh, if you start early, you all have an opportunity to really shape innovations in design, particularly if you have good communication, good collaboration going on, that what you bring to the fight as a GE, you can help shape if you have the right kind of collaboration and the right kind of communication going on. Am I missing something there?
No, absolutely. I mean, I think, I have a couple sites in mind that I've worked on that have been particularly challenging. I mean, where we have, loose, it's a reclaimed, I'm not going to say the site, but it's like a reclaimed land, right? So it's end dumped fill, very loose, so it's susceptible to, liquefaction during a large seismic event, right? Which is essentially, near complete loss of strength for a period of time, during shaking. So that can create large amounts of settlement, right? Bearing capacity failure underneath your foundations. And then, so that's the upper portion of the site. Then there's a bunch of compressible clays. So any new loading will basically, it'll keep settling under the new loading, right? So you have a whole like seismic settlement, just settlement from the new loads. And so for this site, and there's ways to mitigate this without deep foundations. Like deep foundations are expensive. If bedrock is really deep, it's just the cost it can become cost prohibitive. And I know for this one project I'm speaking of, we were getting in the trenches with the structural engineer, like, okay, if we surcharge for the clay and we do ground improvement for the fill to densify the fill, and basically if you preload, the ground will settle, and then you can remove the load, and then the ground the soil will remember basically the load that the max past pressure. Anyway, I don't want to get too nerdy about it. So anyway, we figured out, what residual settlement can we live with? And so, just getting into the trenches with the structural engineer and really like sharpening the pencil on the science, right, can be a huge, spending the money on design, like that example right there, right? Really understanding what you can do and what the building can handle, right? You can beef up the, shallow foundations a little bit so that they can handle the little bit of settlement. And then we're talking about a maximum considered earthquake event, right? So we need to make sure we're not going to have a life safety, collapse or anything like that. But at the same time, it's all about enveloping the risk, mitigating the risk to the level and optimizing it with cost, right? So it can be like a really interesting, creative process where everyone's kind of coming at it from their perspective and it's fun and interesting. And it can be, I mean, it can be huge, right? Because sometimes if we're saying, no, it needs to go on piles all the way to rock and rock is, 200 feet, they could say, no thanks, we're walking away from this site, right? So we want to make sure, we want to, develop. And we were in a situation where I think every place has a housing shortage, right? We want to get creative. We want to make it, everything's expensive, especially here in Guam, right? Everything's expensive. Importing things is expensive. So the more kind of we can get creative and value engineer, I mean, it can be make or break, right?
Yeah, so let's talk about that.
Yeah.
Guam's unique challenges and
Yes.
stuff. Limestone conditions, voids and sinkholes, seismic exposure, extreme rainfall, typhoons, all of this kind of stuff going on in Guam. Can you talk about how these specific Guam challenges are managed by the geotechnical engineer and what you've learned and some of the unique things that you've got to do because of the Guam challenges and conditions?
Yeah. I mean, I will speak to one. I think there's a lot that you listed and they all kind of play into each other. But I think the unique challenge is the karst, right? So karst, limestone, so the basically northern half of Guam and to some extent a bits of the south are primarily underlain by limestone. So we have relatively shallow bedrock, right? And so
So what
most
is
of the time,
karst?
so I'm going to get into it. So
Okay.
most of the time when you have, you get to bedrock, you're like, awesome, we're in rock, we're in good stuff, we have a good foundation, we're good to go. And that's sort of, a very easy problem to solve from a geotechnical standpoint. Most of the time, there's nuances, of course. So limestone, so karst is basically like topography of limestone that so limestone is calcium carbonate, largely calcium carbonate. So what happens is rainwater picks up CO2 in the atmosphere as it comes down, so it becomes mildly acidic. The limestone is basic, so you have a little chemical reaction where you have breakdown of the rock over time. So it leads to, the rainwater will find, water always finds the path of least resistance, right? The pore spaces, the fractures, the joints, the bedding, all of that, and then we'll dissolve it over time. So on a geologic time scale. So that's why, you see all these caves and everything. We have like Paget caves, right? If you've been there. So
Yes.
so we can have rock that basically has a bunch of holes in it, right? So in layman's terms, right? So you can have sinkholes, like you can have maybe a thin layer of harder rock and have a cavern that's underneath and it's, over time it's changing, right? It's going to keep doing its thing, right? Dissolving as it rains. Like you mentioned, we get a lot of rain, right? And so it infiltrates, it breaks the rock down. And so it's very different here because just because you have shallow rock, it's not oh, perfect, we hit rock, we're good. We need to make sure we don't, like, what is our risk of, voids, sinkholes,
Okay.
all that, right? So it's a very unique challenge here. I we've
So is that the definition of karst?
Yeah, it's like it's characterized by a limestone that is, broken down over time due to rain. So
That has
karst is sort
holes
of
in it,
like
voids.
the type of ground surface conditions where you're likely to have voids, potential for sinkhole, that kind of thing. So that has been a very, interesting challenge and to learn how to properly mitigate. It's, before I came to Guam, I was practicing in the San Francisco Bay Area and no limestone there. So it was, learning, like I said, we have a bunch of technical experts, so it's reaching out, okay, who's worked in these conditions? What's the standard of practice? How do we mitigate this? And then
Yeah.
there's that piece, and then there's that now that's what's been done. How do we do it better? What can we bring to bring, better characterize the conditions and come up with more, innovative, cost saving mitigation to solve the problem, right?
Yeah. So if you had to name the three most common preventable geotechnical failures that you see across projects, what would they be and why do they keep happening?
So the biggest are earthquakes. So, earthquake damage, right? Liquefaction, as I mentioned, near loss of, you know, ground strength during an earthquake, landslides, like I mentioned, and then settlement and swell. And so I think it's funny. I mean, the big catastrophic events, right? The landslides, the earthquake damage, all that stuff is gets a lot of attention in the news, but honestly, probably dollar per dollar, just settlement and swell issues probably are the most expensive just because it's everywhere prevalent, right? So
Wow.
yeah, I mean, think about it, right? You see cracks. I mean, I don't know if you've been in old homes too, right? Where you feel like if you dropped a
Yes.
marble, it would roll, and um, so that's really prevalent too. And it is, we can properly mitigate, settlement risk and risk of, shrink swell if you have expansive clay soil. We can. There are ways to treat it and mitigate it. So I think I don't want to say lazy engineering, but maybe, sometimes it's really not looking at the holistic picture of the problem, right? And so I think those are, I mean, calling it a common failure, I think those are the most, yeah, I guess they're the most common geotechnical failures. And a reminder that, the geologic context matters, right? The soil conditions matter. Um, you know, obviously if you're in a seismic region and then making sure that you look at the whole holistic view, right? That you could be developing on a landslide, right? So it's important to make sure you have geologists on your team. And geotech is really the intersection of engineering and geology, right? So it's important to have the geologist to understand, the processes, the geomorphology of why and what this deposit means and how it got here. But then it's okay, what are the geotechnical, properties of this in relation to what I'm building? And so yeah, that's those are the big ones.
Okay. Let's go ahead and shift gears now. So we've been talking a lot about how geotechnical engineering prevents and reacts to problems or whatever. Let's talk about some opportunities for proactive innovation and proactive problem solving front. Where do you
Hmm.
see innovation showing up most meaningfully in geotechnical engineering today?
Yeah, that's a good question. I think, we're getting new methodology. I mean, to better characterize the ground surface conditions, so using more geophysical methods too, which can be less invasive, more cost effective, and show you a lot more of the subsurface conditions. So we're seeing more of that. With technological advancements, we're seeing, able to do, 3D finite element analysis modeling. So you get your parameters if it's a really complicated, you know, problem you're trying to solve. I mean, you're able to model it. And we've had projects where we're doing deep excavations and we're real time watching our model and making sure when we're tensioning off, whatever tieback or, elements we have and seeing how the model responds to the actual ground condition. So I think there's a lot more in that space as well. There's a lot more research in terms of, seismic design. So really getting to optimize the seismic demand on an engineered system. I mean, we have, code-based, you can get your seismic design parameters based on code, the building code, right? But we can really optimize and really, do a little bit more, roll your sleeves up, get dirty, figure out, okay, how will this specific site respond to the likely ground motions? And that way we can actually optimize the seismic demand. So there's probably a lot of, over designing. And I think, you can spend a little bit more money on the design side, which could be a huge savings on the construction side, right? Because that is just a
Yes.
totally different ball game in terms of cost, right? So I think there's a lot more to come in that space, and I think there's a lot of room for that here in Guam. I think, I'm alluding to some talking about geophysics and karst, and I would really love to see, more of that done here too, really getting to understand the level of risk, right? So I think that's
What
where
role is AI playing in your career field?
oh man, it's so I think we're using AI at NGO carefully. I think we want to be early adopters, but we want to make sure we're smart about it, right? So it's right now we're using it definitely to help run analyses and do things quicker, more efficiently, but also making sure we check, right? So you need to always have a gut check on anything. But man, we can, have it look at a whole bunch of borings, at once and have it put together an idealized subsurface profile and cut this cross section. And so it's powerful, right, in terms of time saving, but at the same time, it's still very new. And so we want to make sure we're still doing our due diligence and making sure we're checking everything that comes out of the tool. We're using it as a tool, basically.
Hmm. Understood. We talked already a little bit about your laboratory
Right.
and its accreditation and kind of how that's a huge game changer for the island to avoid having to send samples off island for testing and
Hmm.
analysis and stuff. You know, can you talk a little bit about, um, you know, what kind of impact that's had to like construction schedules and stuff like that, where we're doing all of this construction work in support of the large military buildup, and people are on tight schedules. What it does to have an accredited laboratory here, and can you talk about what does it take? What kind of people does it take to staff a laboratory like that? And do you get them from the States, or do you try to get those um, quality control and specialized techs here on island?
Yeah, good question. So I mean, I think it means meeting the demand, right? So it's just getting lab tests done quickly, accurately. Um, I mean, that's just it, right? So we don't want to be creating delays. So we understand quick turnaround times and all that. So I think being here and having an online on island presence helps satisfy that need. So that was one part of your question. And then second part of your question, so we have hired local staff. We have had staff that have relocated from the States, myself included. Um, and in terms of the staff in our lab, I think because we have 8 people full time here in our office, so we need to always be adaptive and understand the ebbs and flows of, construction, consulting, field work. So things just ebb and flow. And so it takes a person to be pretty adaptive too. So we need to be able to do the field work, but also do the lab work. And so we do right now, we have one dedicated person to our lab, but we also have other folks on our team that are trained. So if the demand grows in the lab, then we can, shift to the lab, and then vice versa. Our lab staff is also, able to go out and do some field observations, density testing, pile driving observations, things like that too. So it's sort of someone that yeah, can kind of do both, and which is great too, because then you really get to see the forest for the trees to understand, okay, this is the test I did in the lab that's directly being used in the field. So if that kind of answers your question.
Yeah, it really opened up my eyes because I had a different mindset. I
Mm.
thought you had like dedicated laboratory folks. And those folks were kept in the laboratory. That's all
Oh
they
yeah.
did, kind of work. This model of them being doing, multi-use, multi-skilled, they're doing some consultant work, they're doing construction support. They're not just dedicated to the lab. It's very interesting. Like you said, it gives them a broader perspective and understanding what's coming in and how their lab analysis are impacting real world projects.
Yeah, totally.
Yeah. So if you were to ask to design a Guam infrastructure innovation stack, what geotechnical or testing capabilities would you prioritize first in that innovation stack?
Here in Guam,
Yeah,
I mean, I think I want to keep trying to push the envelope in terms of, what we can do here. And so I think it's, really finding the right projects that are willing and have, the capacity to take a chance and, like I said, do some more in-depth, geophysical surveys and, subsurface modeling. And I mean, I have big goals on that front, right? In terms of, just up leveling the standard of practice here. So I think um, I see it in the future, and I'm pushing to, like I said, kind of bring different innovation and perspectives and practices to this island, knowing that we do have. It is a challenge, right? It's expensive to bring new practices, but I think there's huge potential here to do it. And so I'm excited for the future.
no doubt, no doubt. Let me ask a specific kind of thing. Like, for example, the use of drones. Could drones be a game changer for you in terms of how you do topography and mapping analysis of a site and the surveying and stuff like that? And is that something you're already doing or looking at doing, or is it not applicable?
We've used drones, and I think drones can help definitely see things from a different perspective, especially we have a lot of vegetated areas too, right? So being able to see how, getting an aerial view of the site, we have done some of that. So I think, for getting a broader geologic context of the site and trying to assess basically, yeah, the sort of more holistic view of a site. We have used it too for big grading sites too, to be able to do topos and really get to understand, grading quantities and things like that. Uh, it's helpful for that. We haven't used it more because we need to see below the surface. So we've used more of like, ground penetrating
Or
radar,
radar?
yeah, electric resistivity testing, things like that, where we can see the subsurface conditions. So the challenge is the mobilization to get these equipment, to the island, and then making sure that it's the right equipment for the project and that it adds enough value, right, to for it to be worthwhile. So yeah, that's
Okay.
sort of what I'm looking into bringing here.
All right, let's talk about the Guam infrastructure reality checks now.
Yeah.
Okay, so from your vantage point, you know, how would you honestly assess the current state of Guam's infrastructure? Where is the system performing well and where is it most vulnerable? I want you to kind of go up 30,000 foot view.
Yeah.
Obviously, as a former airman um, and all of that, I usually think of it in terms of geostrategic or military kind of terms, but you don't have to go down that road. But I
Mhm.
like that's a good context for me to understand resiliency in infrastructure for
Yeah.
a geostrategic mission. So, what say you?
Yeah, so I think like most infrastructure around the world, the infrastructure in Guam is aging. I think we've learned a lot about design and how to design more resilient, since we've built everything, right? Um,
Hmm.
one of my professors in college said, and I mean, it stuck with me forever, right? But he's like, you guys get to be engineers at such an exciting time because my generation went and built everything and we didn't do the best job and now you get to go and fix it with everything that we did in your way, right? So I think it is challenging, right? Because I mean, we have existing systems in place, so we have to figure out, okay, how do we work with the existing systems in place and how do we do it efficiently? How do we make it more resilient when we do it again? So it's not a unique problem to Guam. I think Guam has its own unique challenges, but overall, I mean, we're dealing with aging infrastructure and infrastructure we built quickly, right? So I think we know more now than we did then. And so it is difficult to build at that same pace that we built, when we were really developing, um, you know, America, right? So
Yeah.
it's a different game, and I think, like I mentioned, cost, right? It's very expensive. Labor's expensive, materials expensive, so we need to figure out how to do things more efficiently.
Yeah. So, what are some uniquely Guam constraints that off-island decision makers or stakeholders often underestimate or don't really understand? I know from the military construction standpoint, it's very hard to kind of educate like some of the um, stakeholders at the Pentagon or different headquarters to understand the realities on the ground about why it costs so much or it takes so long or why there's so many challenges with building or addressing infrastructure issues here on Guam. What have you seen? Obviously, you've got a headquarters back in California. What are some of those things that you see, and how do you go about educating those off-island stakeholders?
Yeah, I mean I mean a large part of it is logistics, right? It is remoteness. It is, what do we have here and having to get creative and knowing that, I do get, because I do work, when we're trying to think, okay, this is the problem that we're dealing with. How do we, let's throw ideas at it, right? And when I'm on calls with, our California folks, for example, they'll throw ideas at. I'm like, we don't have that. We don't have that. We don't have that. So it's like, it is educating, right? Like this is what we do have though. So how do we make it work? And yeah, so I think that's a big thing, right? It is availability, it is logistics, it's expensive to import, right? We got to work with what we've got. And that's why I do think it is critical that we really get smarter about design and trying to sharpen the pencil so that we can, you know, that savings will trickle down, right? It has a huge effect.
Absolutely. So you're queen for the day, right? So if Guam really wanted to make some real visible infrastructure improvements within the next 12 to 24 months, where would you focus first for the biggest bang for the buck?
I think our roadways, utilities, drainage, better drainage. I think there's a lot we could do in terms of just the infrastructure connecting point A to point B and I know
So
we
you
have
started with roads. That's
yeah,
interesting.
I would start with roads. I think there's a lot. I think it's low-hanging fruit. I think grounding of utilities is big, but that's very expensive. I
What do
mean
you
it's
mean by that? Grounding of utilities.
well, power lines, right? So I think when we have typhoons here, we do lose
Yeah,
power. After Mawar, I know a lot of parts of the island lost power for
yeah, putting them underground. Yeah,
right, putting them underground. So that is, quite expensive to do, but I mean that would be something as well. But even still, I think on a day-to-day basis, I see um a lot of flash flooding, and a lot of, accidents, right? The roads get really slick here. We get a lot of rain. I think, we could see a lot of improvement just from that in our day-to-day lives, as well as to, you know, aging utilities, right? We have that. So that, I mean, that's something we use every day, right? You don't think about it,
Yes.
you know, it's part of modern living. And so improving I think that's the low hanging fruit where I would start. It's not like the sexiest answer, but you know, I think it is some low hanging fruit.
Yeah, it's interesting that you start with roads. And the first thing I think is, okay, do you want to just improve the existing major arteries? Or are you looking at maybe expanding some more arteries to help unclog some of the major roadways? What would be your focus?
Yeah, I mean, I'm not a traffic engineer, right? So that's not my wheelhouse, but I know we do have congestion, right? So I think the low hanging fruit would be just to try to improve what we already have. As I mentioned, like all of the studies and everything, it's quite costly, right? To do something that's, you know, a new roadway or an expressway or something like to that effect. So I would just say, you know, trying to improve our drainage in the existing roadways too. I know, you know, I do see, you know, I mean, I've never seen flooding. I mean, I didn't live in a place that had that, you know, we didn't in California, it doesn't rain like 6 months out of the year. So it is um it was new to me, right? Having to, you know, have this, you know, these raindrops here are huge and you know, the flash flooding is very real and so I think that would be my answer.
So it's interesting that you gave that kind of sober analysis of it, because what I think I've read into your answer is that Guam's infrastructure issues aren't something that can just be solved overnight, right?
Right.
Because it's going to be very expensive and it's going to be very time consuming to do that. So really, if that's the case, what I would think is that it's going to require steady focus and investment and work
Yeah.
consistently over time to get where you need to, because there's no one big silver bullet. You can't wait for that golden appropriation to fall down and it magically you're
Yeah.
going to fix whatever.
Yeah, I mean, I think your question is challenging, right? In the next 12 to 24 months, I mean, it's that timeline for any sort of design and construction is pretty quick.
Yeah,
So, but I think
it's probably better to ask it like, if you look down the road 10 years, what kind of things could we invest in and address so that 10 years from now, we could have made a stair-step improvement in Guam's infrastructure resiliency.
yeah, I mean, I think all of those things, right? We see the impact of I mean, we see the large impacts of these issues right during these big storm events, right? Loss of power, loss of water, and then just on a day-to-day basis, right, with the drainage issues as I mentioned. So, um, I think that would be where I would put my money.
Okay. All right, let's shift gears again and go to a topic that's always ever present on my mind, and that's workforce development. Let's talk about geotechnical engineering as a career. And I don't want to just limit it to the actual GE engineer, but
Mhm.
also the associated kind of things like the lab techs, et cetera, that support the work that uh, GEs do. So, what
Right.
does it actually take to become a geotechnical engineer? Everything from education to licensure, and how long does it take?
Right. Okay. So the most typical path is to get a civil engineering undergraduate degree. So geotechnical engineering is part of civil. So you'll do, you know, part of your civil engineering degree is, you know, some geotech coursework, some environmental engineering coursework, some transportation, some structural, some general civil. So you'll get exposed to it at the undergraduate level. But if you want to progress and really practice as a geotechnical engineer, it's you pretty much need to get your master's in geotechnical engineering because that's where you really learn the bulk of what you do. As far as licensure, most states and Guam, you get your PE license. So it's you take a specific exam that is for geotechnical engineering practice, and that is the extent in many states. In California, there is an additional, so once, oh, so we talk about timing, right? So you have undergrad, grad school, and then you have to practice for a certain number of years, which varies, state to state, and then you can apply for your PE license. If you pass that exam, and then in the state of California, if you have that exam for 4 additional years, you can take the GE exam, which is a licensed geotechnical engineer. So you need that in the state of California in order to do design for hospitals, schools, critical facilities. So it's another level of licensure, but it's not every state. And I mean, California has, a lot of seismicity as well. And so, just more showing you have more experience that you can,
Right.
the job right. So that's sort of the typical trajectory. A lot of folks also start as a geologist and then they take additional coursework and get a geotechnical engineering master's. So they'll have to do more, of the physics, maybe some math and just general like statics, mechanics, like engineering coursework, and then they can do their geotechnical engineering masters as well. So we have a lot of folks that have done that career path as well, and that's kind of awesome because then they're like a dual hat wearer where they understand the geology and the engineering, so they're kind of badass, if I can say.
So, who tends to thrive in this career field and who kind of struggles? What kind of mindset is necessary to be a good geotechnical
I
engineer,
think
excuse me.
I think you have to be someone that thrives in the gray area. I think there is no black and white with geotechnical engineering. There's a lot of engineering judgment, knowing, what you've seen before and what's worked. I mean, there's no cookbook, right? For this ground condition means you got to do this. It's very nuanced. It's what's the project, what's the risk, what's the ground conditions, all of it. So it's using the tools um and kind of and your experience and your judgment and finding the best solution to the problem. So I think yeah, it's for people that are down to do that, to really come up with a bespoke solution and get their hands dirty. It's definitely for someone that wants to be outside. We do a lot of field work and it's not glamorous all the time, right? It's a lot of the safety vest, the boots, log-in borings, you get dirty, right? Getting in the lab, breaking open samples. I mean, we have to classify soil, so literally getting our hands dirty, right? So um, it's a little bit of all of that, basically someone that runs towards problems that are hard to solve. That's kind of it.
So,
Yeah.
do you think Guam would benefit from having like a workforce development pipeline to grow or build its own geotechnical engineers? Obviously, I know we're early on in this. We just got an school of engineering,
Right.
starting with a civil engineering um, degree program, and it's we're graduating like some of the first engineers on island. But do you think it's worth it to really invest in building a pipeline here in Guam for GEs?
Yeah, I mean, I think so. I think there's an appetite for it. We've hired individuals from UOG and, they've been doing a lot of research at UOG and a lot of geotechnical lab work. So I think, and there's creative ways to get around the master's program too. I know now there's more, remote schooling options than ever before too. So if that's a challenge for some, and then there's always on the job training too, right? So yeah, I think there's ways to really get creative to get that exposure. So I think this is, we talk a lot about AI and what does that mean for everyone's jobs? And I think everyone thinks about it, right? Could AI take my job and all that kind of stuff too? And it's something that I think about, right? And so I think, one thing with geotech, right, is it's always very nuanced, and it's always, getting out in the field and seeing things being built and solving problems. Oh, well, we're finding out about this real time during construction. How do we deal with it? So I do think there's going to be continued need for it, in terms of boots on the ground, and that's really how you learn as a geotech, right? You get out in the field, you see how things get built, and it all kind of falls into place too. So I don't know. I think it would be really great to have more geotechs in this space too. And neighboring islands as well. I think there's a lot of unique challenges in this, in the Pacific here. So I
Yeah,
would think so.
it seems like really in that broad field of civil engineering, you can't go wrong with producing as many people with that background, particularly here in Micronesia, because there's so many use cases for the civil engineer here on Guam, as well as the other neighboring islands. Yeah,
Totally. And I mean, I'm biased, but I think it's a fun career path. It's very different, right? To be able to get out into the world and get away from your desk and really have to see something and scratch your head about it, right? And also it's collaborative. So it's working with, someone who has more experience or, has seen something similar. So I think it's very fun to be able to have work in a very collaborative environment. For me, I think some people really like solitary work and they like coming in and having a normal, like the same day, plugging away. But I think that's not what this career is, and it's fun, and like I said, there's lots more innovation to be brought to this space, and so, I think, yeah, especially, in Micronesia, I think there's a lot to be done, a lot more innovation.
yeah. So we kind of touched on it before, but I kind of want to go back there. Guam's role that it plays in U.S. posture here in the
Mhm.
Pacific. From your perspective, how does the geotechnical engineer quietly support national security, kind of behind the scenes, if you will, in terms of readiness, resilience, and rapid recovery?
Yeah, I think quietly is absolutely right because, like I said, if we do our job right, you don't think about it. A building is only as good as its foundation, right? And so I think, what we're doing is really important because a lot of these structures need to be functioning, right? We're building to a higher level of design category, right? So it's really important that we do our job right. The grading is important, the foundation design is important. All of these little things, right, add up. And so I think, that's how it's all done, and it has to be robust and it has to be resilient. And we do have challenges that, we are working with a bunch of, things in our way, right? Every time we do work on one of these bases, I mean, they've already been built, and so we're working around what's already there. And so yeah, quietly is, if you don't hear about us, we did our job. If you don't think
That's
about it,
right.
we did our job.
That's right. So, Caroline, I think I've heard it in the conversation that we had a little bit earlier, but uh, if you were talking to policymakers, your suggestions, if you were queen for the day, would be improvement in the roads, drainage, and grounding of utilities. Those are three kind of big focus areas that you would do to improve infrastructure here on Guam, and that would make a huge impact. And that led us into a conversation about uh, neither one of those three are like a quick silver bullet. It's something that you're going to have to invest in and focus in consistently over time and making small investments, small projects so that over the long haul, things get better. Am I, is that a good characterization?
Yeah, I think it's a good characterization. Little by little, I mean, I think it's incremental progress.
Yeah, yeah, yeah. Wow. So, Caroline, I tell you, it's been an outstanding conversation, as I knew it was going to be. Thank you for pulling back the curtain on geotechnical engineering and for helping us understand how the ground beneath our feet shapes Guam's future. I tell you, for our listeners tuning in, if they want to get in touch with you, what would be a good place to, reach out to you or NGO to hire you for your services or to ask questions or to connect?
Yeah, I mean, you can first of all just drop by our office anytime, Monday to Friday, in Harmon if you're around. We're happy to chat with you, or someone's going to be there. We're happy to chat. You can email us, right? You can email, it's my first initial last name at NGO.com. You can email info@ngo.com, and all our numbers listed and anything, but we're happy to help. We're here. We're committed to our community, and we want to bring, like, that's, when you asked me to be on this podcast, right? I want to find my tribe of people that are interested in this. If this resonates with you, right? If you're like, yeah, I want to figure this problem out. I want to, work smarter and really come up and really sharpen the pencil and design so that, we can be creative. So if you're down for us to be, creative with you and we can add some value, I mean, let's chat. We'd be happy to help.
All right, great parting words. And I would encourage anybody who's interested, please reach out to the NGO team. To the audience, thank you for tuning in. I sure learned something today. I hope you did too. Be sure to like, follow, share, and subscribe. And don't forget to check out my Innovate column in the Pacific Daily News every first and third Friday of the month. Until next time, whether at work, at home, or at play, always innovate. Thank you.